you. I'll let you all join. If you want to say hi, say where you're from, you can post that in the chat. We've got a few different places. I'm here from the UK in London, and then we got Mike. Where are you? Where are you, Mike?
Yeah, I'm in the San Francisco Bay Area.
Cool. So that's the other side of the ocean, and then we got Vlad as well.
I'm based in Colorado.
Okay, cool. And then yeah, but if you're gonna post in the chat, make sure you change it to say to everyone. Otherwise, it's only gonna send it to us, which would be quite boring. We'll just give people a few minutes. We'll give it maybe 1 or 2 minutes and then we'll get started. And we've posted a link, as you can see, so it's on YouTube. And if you want to watch it afterwards, you can get it on that link as well. So we've got two people from Istanbul, somebody from India. So we've got it going a bit more east. So that's cool. Must be a bit later in the night there. We've got South Dakota. We've got more from USA. Got someone from Pakistan. Cool. Welcome to everybody. Oh, we got Iceland. Nice. France, Taiwan, Ukraine. We've got scattered all over the globe today. Cool. Welcome, Giovanni, Rodrigo, Vedran. Oh, we've got Croatia, Brazil, Italy. Great. Okay, yeah. So we got two speakers today. So we've got Vlad and we've got Mike, who you've already met. And I think Vlad, you're going to be starting, right? So I'll hand over to you. If you have any questions, you can either ask them on the chat, and I will collect them, and we'll probably do it at the end, or if there's a gap, I'll ask it there. So that's the best way to ask your questions. Otherwise, let me hand over to Vlad, and we'll get started. Cool.
Let me try to share it.
Yep, I can see. So that looks good.
Works. All right. So let's talk about LogHouse, the observability solution for ClickHouse Cloud. Here we go. Let me introduce myself first. My name is Vlad Silverstuff. I lead observability team here at ClickHouse. I joined ClickHouse about 2 years ago, but I was working with the database itself since 2009 back at Yandex when it wasn't open sourced yet. I formerly worked at Datadog, Dropbox, Meta, and Yandex. I'm super passionate about building reliable and high-performance distributed systems. For instance, at Dropbox, I was part of the team that built Magic Pocket, a block storage that holds all the customer data. I'm based in Colorado, and if you want to connect, here's my LinkedIn. So here's what we got lined up today. First, I'll share why we decided to build LogHouse, our in-house observability platform. Then we'll take a quick tour under the hood and look at the architecture. And if everything behaves and live demo god's not angry, I'll show you a few demos in action. So let's kick things off with a quick intro to ClickHouse Cloud. So ClickHouse Cloud is a fully managed ClickHouse database service. It's available across AWS, GCP, and Azure, supports deployments in over 20 global regions, and today it operates thousands of ClickHouse instances around the world. If you're curious about technical details of how we built it, we have a pretty cool video and blog post. You can check them out with this QR code on the slide. So yeah, take a look at it. Here's a high-level view of ClickHouse Cloud architecture. We separate compute and storage for ClickHouse instances that we host. The compute runs on Kubernetes, like EKS, GKE, AKS, depending on the cloud provider. And all data is stored in object storage, like S3 or GCS or Azure Blob Storage again, depending on the cloud provider. From the observability standpoint, ClickHouse servers are very, very chatty. They generate tons of logs. If you're curious, there's been a meme about it. Just Google calming down ClickHouse. It's a meme. And also, we don't just have ClickHouse servers in our infrastructure. We also run a bunch of microservices in Kubernetes, and they produce their own share of logs too. So before building our observability platform, we laid out a clear set of requirements. So first, we wanted to dock with ClickHouse Cloud and the same integrations we offer our customers. If we're building it, we're going to be using it ourselves, right? Second, it had to be a Kubernetes native deployment, hosted exactly the same way we host customer instances. No special treatment here. And since ClickHouse is open source at its core, supporting open standards was non-negotiable, and because of that, for data collection, we chose OpenTelemetry. It's the industry standard, and it fits perfectly. We also need a strong support for high cardinality data, something ClickHouse is uniquely good at, like working with detailed system tables, which ClickHouse server is specific. We'll get into it a little bit later. It's an insanely high cardinality data, an interesting problem we had to deal with. Another big one, we require at least 6 months of telemetry retention. That's critical for retrospective incident analysis. Sometimes you just need to dig deeper, and like months later, the incident has happened. And finally, no sampling. We want everything. We don't want just a small slice of the telemetry. We want store it for a long time. We want to be able to process it non-aggregatedly. And yeah, we want to be cost effective. So quite a set of requirements, right? So let's talk a little bit about high cardinality. Where does it all come from? So let's take a look at the example, the query metric log system table in ClickHouse. It keeps a history of memory usage and metric values from the system events table, but it's on a per query basis. Each query is unique. We're tracking detailed metrics for every single one. The amount of distinct data points grows really fast in this case. And yeah, that's a pretty good example of high cardinality. So that's like the top part of the query metric log table. So overall, it has 817 columns. That covers everything from memory allocations to specific event counters inside the ClickHouse engine. It's a lot of fine-grained telemetry, but it's what makes deep investigations and performance analysis possible. Since we're talking about query logs, it's important to mention how we handle privacy. In vast majority of cases, we collect redacted versions of queries. We usually don't need the full query text, and we take privacy very, very seriously. There's a small subset of non-redacted queries that we collect specifically for the automated blue-green deployments, but those have much lower retention and are used strictly for system verification. Access to any unredacted data is tightly controlled and audited, and importantly, the customer data never leaves the region where it was originally stored. Another good example of the high cardinality data is the system part log table. The table reports events related to data parts and merge tree family tables, things like part creation, merges, deletions, or downloads. It's incredibly useful when you need to investigate rare cases of lost or corrupted data. By looking at the part log, we can trace exactly what happened to a data part over time, which is critical for root cause analysis and complex incidents. So here's a good example of what is stored in this table. And there is also a column profile events that captures a lot of same performance counters that you'd find in the query log and query metric log. In query metric log, it's exploded. Each value in this profile events array is in a separate column. In query log, it's also comes as a map. It records dozens of detailed metrics for every single operation on the part creation, merge, deletion, download, you name it. And that's another great example of high cardinality telemetry. Every part operation generates unique rich set of metrics, and we can later use for deep analysis. So why do we collect this data? Well, ClickHouse, first and foremost, a database company, and reliability and durability is absolutely core to what we do here. In ClickHouse cloud instances are dynamic. They can idle, they can scale in, they can scale out depending on the workload. And that makes this telemetry critical. If something goes wrong, we still need to investigate, even if the instance is idle or has already been shut down or terminated or sleeping or like it was scaled in back. So the pod that was running this particular service is not available anymore. And without this historical telemetry, troubleshooting the dynamic environments like this, it would be nearly impossible. So that's why we built it. So to solve these challenges, we built LogHouse, our internal login platform. It's powered by ClickHouse, OpenTelemetry, Grafana, and HyperDX. And it's designed specifically for high cardinality and high throughput telemetry data. It supports both real-time investigations and deep historical analysis. So whether the issue just happened or it's months old, we can dig in. There is a pretty deep blog post about the OpenTelemetry part of it that we posted about a year ago, and we're working on the new one. If you're interested in more technical details that we won't be able to cover given the time constraints today, please check it out. There's a QR code for that. So LogHouse. LogHouse actually has two separate pipelines. The first is the OpenTelemetry pipeline. It captures telemetry from our microservices, logs, traces, and basically everything that Kubernetes applications write to the console. The second is our high cardinality events pipeline, which we call SysX. It's short for System Tables Exporter. SysX is responsible for collecting detailed telemetry directly from ClickHouse system tables, the stuff with tons of metrics and dimensions that I just demonstrated. Traditional systems usually struggle to handle that, but with ClickHouse it's possible. So just to give you a sense of scale of what we're operating here with ClickHouse. Combined, these two pipelines ingest about 415 terabytes of raw telemetry data every day. Thanks to ClickHouse's compression, we shrink that down to around 23 terabytes of stored data that ends up in the object store. That's roughly 18 times compression ratio. In total, we're ingesting about 2.6 trillion events per day. Since we're keeping data for 180 days or 6 months, it gets even crazier. That's up in total for 86 petabytes of raw data, around 5.4 petabytes after the compression. And across this retention window, we're talking about 100 trillion of events stored. If we split this number by pipeline, here's what we see. For the OpenTelemetry pipeline, over the 6-month retention period, we're handling about 15 petabytes of raw data, which compresses down to around 757 terabytes. And on the ingestion side, it's roughly 1 million events per second being ingested. On the SysX pipeline, it's bigger. Over 6 months, we're talking about 71 petabytes of raw data compressed down to about 4.6 petabytes. And on the ingestion side, it's handling around 30 million events per second. All right, so enough with numbers. Let's talk a little bit about how it's done. So when at a high level, any observability platform, including LogHouse, has 3 major components. First, telemetry ingestion. We need to efficient and scalable data collection plus enrichment to make this data more useful and explorable. Second, telemetry storage and processing. We have to store massive volumes of data and still support fast and flexible querying. And finally, visualization and user interface. All the data has to be accessible through the intuitive dashboards or tools that real humans can actually use to debug and explore. So for telemetry ingestion, we use, as I mentioned, 2 different pipelines. OpenTelemetry for general purpose telemetry from microservices and KDIS and collecting the telemetry from cloud service providers, like exporting logs from CloudWatch, for instance. And we have a SysX pipeline for high cardinality events. It's ClickHouse specific telemetry that's pulled directly straight from the system tables. For telemetry storage and processing, the part was easy. It was the easiest part. Like we use ClickHouse, of course. Our business is to run ClickHouse, so that was a no-brainer here. And for visualization user interface, we rely on Grafana and HyperDX to build intuitive dashboard, make it data easy to explore. Now let's talk about telemetry ingestion. Start with OpenTelemetry. The OpenTelemetry pipeline that we built is pretty classic. We have Kubernetes applications running on the nodes. Each node has an OpenTelemetry collector agent that tails their console logs. Those logs are then sent to a centralized OpenTelemetry collector gateway, which we run a bunch in a region that handles enrichment, post-processing, and finally inserts data into the ClickHouse. Another important thing that the OpenTelemetry collector gateway does, it batches the inserts. ClickHouse operates best when the data that is inserted is batched. So they are pretty chunky. They batch blog messages up to 100,000 rows, I believe. And yeah, send them to the ClickHouse. Then, once data in the ClickHouse, tools like Grafana and HyperDX query, we use it, or direct ClickHouse client access to the database. We use it to power our dashboards, visualization, and exploration workflows. So that's our single region setup. That's pretty much the same diagram, just transposed a little bit. But we run in multiple regions. So since we run in multiple regions, we need to somehow solve this problem. So the way how we approached it is each region collects and stores its telemetry separately. We do that to avoid sending raw telemetry data across regions for both cost efficiency and performance reasons. And then using ClickHouse cluster, when we have the ability to query across regions. We can federate queries across different regional instances, and if we need to query a global view. On top of that, on the visualization layer, we built a Grafana Scenes app. I'll show it in a bit. Lets users connect directly to the specific LogHouse instance for a particular region if they need some localized telemetry from this particular region to avoid fanning out the query using the federated setup. All right, OpenTelemetry is all. Let's talk a little bit about SysX. SysX uses very similar setup. Just to save compute and avoid the overhead of extra serialization and deserialization, we replaced OpenTelemetry for this specific case with an in-house developed scraper. We switched from push model to a pull model. The SysX scraper reaches out directly to the customer ClickHouse instance, grabs the telemetry from the system tables there, and inserts it straight into the regional LogHouse servers. It's much more efficient. We return the result in the ClickHouse native format, so we really avoid additional serialization, deserialization step that we had to do with OpenTelemetry. To avoid putting extra load on customer instances, we monitor it for errors. And if we detect any errors or like CPU usage spikes, we automatically back off. And like we have this ability now that we're pulling and not pushing. So whenever the instance is CPU usage is gonna go down on the customer instance, we're gonna re-reach it. We try to scrape the data from the last checkpoint when we did scraped it last time. And we're not stopping there. We're actively working on next-gen scraping that will completely avoid impacting customer instances. It's planned to roll out later this year. So that's going to completely eliminate any impact from telemetry collection. Now, a little bit about telemetry and storage and processing. LogHouse is fully built on top of ClickHouse and powered by ClickHouse Cloud. We are dogfooding the exact same battle-tested architecture that we offer to our customers. No internal-only magic, no shortcuts. We use OpenTelemetry schema that we recommend our customers using and that we contributed back to the ClickHouse exporter in OpenTelemetry. So no secret sauce there. Thanks to ClickHouse high compression efficiency, we see about 15 times compression on average. And in some cases, it goes up to 100, but on average, it's 15 times. Because of ClickHouse, it supports cross-regional queries, meaning that we can run distributed queries seamlessly across multiple regions without moving the massive amounts of raw data. And the whole system is horizontally scalable. So it's blazing fast. Now about the visualization. We are also dogfooding the ClickHouse ecosystem for visualization. We have two main tools that we use for dashboards, Grafana and HyperDX. For dashboards and data exploration, we leverage the existing Grafana integration. It's great It's a great fit for building dashboards on top of ClickHouse data using the ClickHouse integration, the ClickHouse data source that we own and we contribute back to Grafana. We also built a custom Grafana scenes app that helps to route regional queries more efficiently, so users can always hit the right LogHouse instance based on where the data lives. And on top of that, we use HyperDX for logs and traces exploration. HyperDX is pretty cool. It's a schema-agnostic exploration tool based on ClickHouse. It supports Lucene style query language, makes it super powerful, flexible. It built on top of ClickHouse, and as you might have heard, HyperDX recently joined ClickHouse. Mike will dive into more details about HyperDX later. But now let me show you what it looks like, what our Grafana Scenes app looks like. Now I need to share a different window. Here we go. All right, so this is the hotel pipeline app it's the app that is looking at the data collected from the hotel pipeline. This is our developer environment, no customer data here. So that's what it looks like. Like you have a selector of the namespaces, you can pick multiple here. You can get the logs for last 30 minutes, or last hour. Can zoom into this range if you want. Get back to 30 minutes here, and let's see what is the distribution of service name and severity. Or just like what service generates most logs here. So yeah, Tailscale DNS server is in the lead. Can explore here. We have like filter panel to the left. You can see the what it does under the hood. It generates the SQL query to this specific database, to this specific data store. And you can type in your query if you want, or you can like get the full query, full generated query from here, take it to your ClickHouse client and use, and it shows what data source to use over here. So that's and then if you just see this is the explore panel. Now let me show what sysx looks like. Sysx is the high cardinality data. So let me take a look at it real quick. I hope I share it the right window. Let me do it again. Here we go. So we're looking at the query log here. This is the instance that is in AWS. It's in US West 2. We have a cellular architecture, so in some regions we have multiple cells. And those are the query logs from this instance. As you might see, the fields here are replaced with question marks. This is how I redact our queries. Yeah, you can add some extra columns here. Let's say read rows, read bytes. Here we go. You can explore the full event here. Filters are also available here. And then if you want to switch to another instance, let's say this one, it automatically populates the credentials and changes the cluster that it talks to under the hood. And then you run the query, and you see the results. Yeah, that's a good example of the data redacting. That's it. We are limited in time. I want to pass it to Mike next to talk about HyperDX and demo it.
Yeah, thanks, Vlad, for the great demo on LogHouse. So I'm Mike. I come from HyperDX, where I was co-founder and CEO. And as Vlad shared, and we announced recently, we recently joined ClickHouse, where we'll continue developing HyperDX, continue developing the open source product, and of course, bringing a lot of the user experience and developer experience we've built on HyperDX to ClickHouse, broader ClickHouse users and customers as well. So I'd love to do a quick, well, first maybe a quick explanation of like the observability stack deployment that we see that our customers and end users are doing, and then dive a little bit into the product and kind of sharing what it's all about. So let me get my screen shared, and hopefully you guys can see a little bit about that. So as you can see, what we are calling the ClickHouse observability stack is really similar to what Vlad shared, where you have your instrumented application, you have your instrumented infrastructure, whatever kind of source that's coming from being passed into OpenTelemetry collector, and we have the OpenTelemetry exporter available within there to insert into ClickHouse. And on top of that, of course, you can query in a variety of different ways. Vlad just showed off the Grafana integration with ClickHouse. And then also, of course, with HyperDX, we expose a really more like observability native or exploration native kind of workflow for engineers as well. And, of course, they're just kind of like different trade-offs and different kind of opinions in terms of what tools and what workflows work best for your team. But I'll be showing a little bit about HyperDX itself. So just kind of jumping in here, we can kind of resume live tail. So this is just a small instance running our demo logs at the moment. You kind of see, all the logs that are coming through on this specific instance. It's really easy to also do searches on top of this. So for example, hey, I just want to find all the, logs that are doing disconnected. We support a Lucene-like syntax on top of ClickHouse. So this isn't using the Lucene search engine or anything like that. It's just a syntax. It transpiles it into SQL and runs on top of ClickHouse. It does a variety of optimizations under the hood as well to try to make sure your query is performant as possible on top of your data. And then, the syntax is quite powerful for, most of your everyday needs. So very easy to do, column, property, or even map, property is really easy to do within the syntax. But of course, sometimes your queries are a little bit harder to express. Maybe you need to drop into regex. Maybe there's a custom ClickHouse function you want to call. You can always use the SQL mode as well, and it will do exactly the same thing for you. So you really get the benefits of both worlds, both a fast exploration workflow, as well as the full power of ClickHouse available to you. So once that you get your responses back, one thing to note is that we only select, a few columns, usually only looking at a few columns at the high level, and we will actually just select those columns. And then when you actually click in, we will then do the work of pulling out all the column values for that particular row. So, only for a specific gradient, basically, we're doing select star on top of. For the full search, we only select the columns that you actually care about. So this makes it really easy to, preserve that familiar pattern where you just look for the top level columns, click in, and be able to see all the properties of that specific log, while also taking full advantage of the columnar nature of ClickHouse. And then one nice thing as well is that, high cardinality is not just limited to logs. Traces are certainly a part of that story as well. So let me go find a log with a good trace, actually. So maybe this one, or I guess a bit of ingestion delay on some of these traces. Let me see if I could find. Well, I can talk about infrastructure a little bit earlier, maybe. So logs is also kind of be able to correlate with infrastructure. So while a lot of high cardinality is really useful within ClickHouse, another thing that's also really useful is the infrastructure correlation as well. So we also have native support for pulling in Kubernetes metrics, for instance. So in this case, it's really easy to go for, hey, here's a log that this pod emitted, to here are the correlated infrastructure metrics related to that given log line at that point in time. So it's really easy to understand, hey, if there's an error that's happening, what is the resource utilization of that pod? Is the pod maybe running a lot of CPU, being CPU constrained, or is it, hey, like there's actually CPU pressure on the node level or disk pressure on the node level as well? So be able to really easily pivot from signal to signal to kind of get what you need out of it at the end of the day, basically. So that's maybe a quick look, and let me see if I can still find a nice trace. This is a shorter trace. We also do log to tracing correlation. So again, it's really easy to go from a given log message here to the different spans are emitted in the same trace. So again, kind of easy correlation between the different signals that you're sending into ClickHouse today. A few other things that we do, I guess I could show our kind of out-of-the-box APM view as well. So if you send your traces into ClickHouse with the OpenTelemetry kind of convention, you're able to have some of these built-in dashboards to help power kind of your investigation use case. Here's more of like a traditional APM kind of use case where you're able to understand how your servers are doing, request rate, throughput, latency, slowest endpoints, diving into specific endpoints, what the slowest spans are for the given endpoint, slowest requests for the given endpoint. So really give you that quick ability to turn ClickHouse into a full-fledged APM platform, a full-fledged logging platform, and be able to correlate across those signals really easily as well. And of course, one big thing that is really powerful within ClickHouse is being able to really visualize any data that you want on the fly. So again, HyperDX exposes a really nice workflow where it's easy to pick, an aggregation function. Say, hey, I want to know the 95th percentile of duration of our spans, maybe grouped by span name. And then, for all spans that have the word Prisma in it, right? So being able to do exploration like this really quickly is definitely a strong point of HyperDX, where maybe not all your developers are really familiar with perhaps the schema or like the query or like the specific setup of your application. But it's really easy just to start kind of using the autocomplete, using the different kind of grouping and filtering and aggregation functions within the HyperDX UI to quickly kind of drill down to what you're looking for. And of course, on top of this, it's really easy to turn that into a dashboard. The flow is exactly the same, where I could just do we could do something different, where I could pick all the logs that talk about disconnecting, and again, maybe group by the severity text level here. And we're able to really easily create this chart, just save it, build a set of dashboards, and then share it with the rest of the team, as well as alerting on top of these charts as well. So you're able to, build thresholds saying, hey, if there's, more than 5 disconnected log lines within a given minute, you should go fire off a webhook or an alert to actually tell us what is going wrong here. There's also a lot of other features within HyperDX that maybe would be we could dive into some of the time. I could go check out our known as well. Other things around like session replay, so the ability to actually see the sessions that our user is doing, as well as be able to monitor Kubernetes clusters, as well as be able to monitor ClickHouse itself. So there's a lot of like pre-canned dashboards and also a lot of different signals that we're able to correlate together within the platform. But otherwise, that's a pretty quick kind of rundown through the platform overall. Awesome. And I think I'll pass it either back to Vlad or is it back to Mark?
Cool. Maybe back to me. I see there's been some questions, but I think Rich has been answering them by hand. We've got maybe a couple left. This one might be for you, Mike, I think. Is it possible to view all the metrics from different sources for the records with the same trace ID? It's easy to do in open source search, but difficult in ClickHouse.
I think, let me take a look at, is it possible to view all the metrics from different sources for the records with the same trace ID? So I guess I guess is this like talking about metrics exemplars and linking with trace ID? I don't know if there's a quick way for me to get clarification on the questions on the
Yeah, we
call.
can ask Tim. Yeah, if you can clarify the question. Yeah, you can write something on the chat.
Yeah.
And then what have we got? We got another question while we're doing that. Are there any ClickHouse functions to visualize histograms exported via OpenTelemetry, especially referring to bucket counts and explicit bounds that get exported? I'm not sure of that one. It's Jorge, second one.
Oh, I see. Oh, Vlad, do you want to take it? I saw you unmuted.
Well, not yet. That's the quick answer. If we're talking about like getting this from the database, like in a ClickHouse client or anything or something like that, then not yet.
Yeah, and just to add on to it, it is something that we're adding onto HyperDX. I think you could technically define, I think there's an issue open somewhere where someone shared a function. You could define a function to do this. Within HyperDX, we're also working on a few queries to do the percentile aggregations on those histograms as well. So maybe there's something we can also share about that.
I think
Cool.
there was an
Tim has
important question, Mark, if you don't mind me interrupting, that was answered in chat, but for those who are on YouTube or watching the recording, they might not see it, which is, are the OTel gateway and the OTel connector internal to ClickHouse, or are they open source? And the answer, thank you, Rich, for answering, is that the collector is there. It uses the OTel spec. You are free to use it. This is not LogHouse, as we've implemented it, is very, very specific to our infrastructure as we dog food what we're doing. But even HyperDX, from the perspective, feel free to join either of our GitHubs, keep an eye on what we're doing and what we're building, and use it on your own infrastructure where you need. Back to you, Mark. Sorry, I wanted to make sure that one got answered.
Yeah, cool. So, Mike, if you look, Tim has clarified his questions. He says, I think he's talking about when you were doing the HyperDX demo, you showed a page where you showed the traces from different apps. Is there a way to get from the trace? How do we get from the traces from all the apps in the chain? How do we get the traces from all the apps in the chain?
Yeah, that's a really good question. So the pattern that we recommend is that you do forward all the traces to a single tracing table, and then you can query by trace ID. Basically, the application HyperDX will do this for you, where you click on a trace, it'll understand what the trace ID is and look at the trace and logs table to find all the related spans and logs for that trace ID. Within ClickHouse, there's no need to really shard your application by different tables or anything like a table per application. It's highly performant. Really, we recommend looking at the primary key or looking at the partition, possibly the partition as well, if appropriate for use case, to keep everything with a single table, and then use the keys or partitioning statement to keep things performant in that state. But you don't have to worry. I know there's other databases where you have to worry about, one table per app or one DB per app. That's not really a limitation. With the ClickHouse, you're able to safely do that in a single table.
Cool. And then we had another question. How can we set up on .NET and Java? So at least what we've showed in here is the OTel collector, and you can do that for .NET and Java. Rich has replied to that on the chat, so just repeat that one. What else? I think we had some other ones. Yeah, so somebody was asking HyperDX. This was Vladimir. HyperDX, does that mean Grafana's not going to be developed anymore? So they're kind of, I guess for slightly different things. So the Grafana stuff is still being worked on. And what table schema do you use to provide, this was Tim as well, to provide fast exploration queries? Do you use Bloom filters or some other optimizations? I'm just going to paste the answer. If you can't see it, I'll put it onto YouTube. So this Vlad already replied to this one. If you are curious about that, we post back anything we do back to OpenTelemetry. So I've posted the link that Vlad posted. What else do we have? Okay, we got another one. This is from Yusuf. Does HyperDX intercept, Mike, you can probably see this, intercept the telemetry data ingestion flow to enrich or transform the data before it puts it into ClickHouse? Or is it using the OpenTelemetry format out of the box?
Yeah, so HyperDX in the demo I showed was using just the OpenTelemetry collector and the exporter to insert that data within ClickHouse. There's actually a variety of ways you can get data in ClickHouse. Through basically almost every ingestion method I think is supported at this point, more or less. And HyperDX will actually work on top of it. I know we talk a lot about OpenTelemetry. We love OpenTelemetry. It's a fantastic standard and a fantastic project as well. But really, if you're using any other tool as well, any other pipeline or ingestion path, or even custom schemas that are very different from OpenTelemetry, all that is supported within HyperDX. It's very flexible. You can define, how specific column or columns or expressions map to observability column sets like timestamp, trace ID, etc. So all that is really customizable within the application, and it'll still work just as well with your custom data or with the completely standard OTel schema and ingestion pipeline as well.
Awesome, thanks, Mike. There's been a lot of questions about HyperDX, and I think it's made it really clear why HyperDX and ClickHouse have joined together, and log traces, metrics, and infrastructure statistics, and also APM. Like, wow. But there was an interesting question that came in on YouTube that I want to flag. And Vlad, this is a question for you. And it's more of a design question than an implementation question. The question was, do the costs for ingress and egress traffic factor into the design and implementation of what we're building with LogHouse in ClickHouse Cloud?
That's a really good question. So there are few optimizations that we did that we embedded in our design from the very beginning, such as, first of all, we keep all traffic regional. Like, we do not export a raw telemetry to another regions. So we eliminate the cross-traffic component here, cross-region traffic component here. But there's still a cross-AZ traffic component. So to do that, to mitigate that, we try our best. We use a topology-aware routing when we're routing traffic from instances that are being hosted in some certain AZs to the LogHouse clusters and OTel collectors, collector gateways, based on how we prefer to ship the traffic into, if there is an available collector gateway in this particular AZ. And then from the gateway collector, we ship the traffic to the nearest, preferably in this AZ, ClickHouse instance that's available there. The way how ClickHouse Cloud service, which consists of a few replicas across different AZs, is like we run a few replicas in different AZs for reliability purposes. So if they're available, we prefer to route to them. If they're not, well, we have to get this data somewhere, so we ship it across the AZ, but never cross-region.
Yeah, and I also want to jump in really quick about the Grafana question earlier, the question around, will the Grafana plugin still be developed after the acquisition of HyperDX? And the answer is definitively yes. We're very vested in the Grafana ecosystem. Vlad has demoed kind of how that's being used internally. And also something to note is that, of course, the Grafana data source plugin that we support, as well as HyperDX, there's a lot of commonalities between the patterns we're trying to expose to users. So if anything, we're working on figuring out how do we expose some of the nice user experiences that we've built within HyperDX to be available within Grafana as well. So if anything, we're basically increasing our investment and our learning and our ability to develop the right user experience on top of ClickHouse, regardless of kind of where it sits. Some people love and use Grafana for all sorts of use cases. We definitely want to meet people there and have ClickHouse available within there. Some others are looking for a little bit different of a workflow and style, and HyperDX will support users there. And areas where we can share our learnings and code bases as well. We'll certainly do that ahead as well. So I do want to emphasize that, if anything, we're increasing our investment and our focus on this as opposed to kind of, putting one aside for the other.
Cool. We've got some more. So Yusuf, is metric cardinality a problem as it is on Prometheus when using ClickHouse? I don't know. I guess either of you can do that. Mike, since you were talking recently, maybe you can do that one.
Yeah, absolutely. So ClickHouse's storage of time series is definitely different from Prometheus, where Prometheus has a time series built out for a specific set of labels. On the ClickHouse side, we take a different approach, at least with the OTel schema. There's many ways to, store metrics, of course, within ClickHouse, but the OTel schema stores in a way where it's not per unique label combination creates a new time series. They're put in a format where you're able to have basically multiple sets of unique labels within a given within the table, actually, within even given parts and stuff like that as well. But the short answer is no, the layout is different, so therefore you really don't hit those limits as much as Prometheus. So cardinality explosion is not as difficult to deal with at the end of the day compared to Prometheus.
Maybe one for Vlad. How would you implement security-based use cases as there is no scheduling in ClickHouse? I assume this means alerting, does it? Or what is it? I'm not entirely sure. Maybe Vlad knows. What does that mean by scheduling? And do you already do this?
Can you clarify what you mean by scheduling? Like we do have some
anonymous attendee. Can you clarify what you mean? You might have to become unanonymous unless there's a way to be anonymous while clarifying. Let's do another one. Have you found any tricks for improving latency when searching and retrieving small number of log events? E.g., fetch a page of 20 log lines that match an arbitrary set of user-selected filters, where you can't use the primary key to do that.
I can answer that. The way how we approach that internally in LogHouse, we have, depending on the query, like we try to identify the query patterns, the most common query patterns that engineers are using, and we set up a materialized use for them. Like we can materialize some of the attributes, we can parse out some attributes and materialize them as a column at the ingestion time, and then we can use it as a sorting key additionally. And we also can build skip indexes on top of that. So another way is to like we're testing this out right now. We recently released a new JSON data type, which automatically transforms your JSON like an OpenTelemetry schema that would be resource attributes or log attributes, can explode it into separate columns, and you can build under some conditions you can build use it as a primary key for the table. So that's another approach that regarding the OpenTelemetry schema that we're getting into. But basically, learn your patterns and pre-aggregate data in a way that the answer in it is going to be fast. Querying is going to be fast.
Yeah, and just to add on that, I forgot, Vlad, if you mentioned the materialized columns as part of the JSON answer as well.
You did it.
Oh, sorry. I must have been reading chat.
Okay, what else have we got? Okay, so we've done that one. Okay, anonymous is back. So yes, I mean a scheduled execution, of a search as done in HyperDX as alerts. So I guess they're asking, how do you do alerts in HyperDX?
Yeah, so in HyperDX, we do have in the application layer built for scheduled searches to be run and alerted on. I think so that's kind of just how it works. There's a UI for selecting, the search you're trying to do, the threshold you're trying to hit, above, below, and then the destination that you're trying to send to, basically. Hopefully that answers that question correctly.
Yeah, to add to that, as of not so long time ago, ClickHouse also supports refreshable materialized views. In LogHouse, we use refresh will materialize to use for this particular application. Like we have a set of RMVs that periodically recalculate, like go over the logs and pre-calculate some metrics that we use then to alert on.
Cool. And then I think this is another question from Victor while Vlad was explaining about materialized view. So is all the event data stored in the materialized view, or do you use it as a reverse index back to the main table?
It depends on the use case. Like if the payload is really big, it doesn't make sense to store it in the materialized view. But if the payload is relatively small, or like very denormalized, so you have like a very wide table, then compression is going to be great. It won't do any any storage implications here, so we just store it as is.
Cool. And then we got one more. So Ilya, can you configure, I guess this is with HyperDX, several different ClickHouse clusters and visualize traces from them all in one central interface?
Yeah, so in case that question is either for HyperDX or Grafana, the answer is definitely yes. Within HyperDX, there's a concept of connections. You can set up multiple connections. On top of that, you can set up multiple sources which are basically mapped to tables within ClickHouse. So you can have any arbitrary number of tables over any arbitrary number of connections, and you can all build them in the same dashboard in that case.
Cool. All right. I think we've done everything. So cool. I think we're more or less done then. So thanks to Mike and Vlad. I guess Tyler, we should tell people if you're interested in our next ClickHouse community call. That's on Tuesday. That's 25.4. I'm going to paste the link onto YouTube and into the chat.
Indeed. And if you happen to be based in or near the San Francisco area, we're hosting our first user conference, which is called the ClickHouse Open House on May the 29th. You can just type ClickHouse Open House into your favorite search engine of choice, and it will show up. Or you can click the link that's in chat now. Also, if you're interested in learning more about LogHouse, again, the search machines are your friend, or HyperDX, the same. Always, we encourage you, come to the ClickHouse repo, give it a star, give it a follow. If this sparked interest in you, you also feel free to go to clickhouse.com/Slack, which will redirect you to our Slack community. You can join there, ask questions. Our team is super engaged, and we are more than happy to answer them as they come through. Perfect. So with that, I think we will call it. It was amazing. We greatly appreciate all of you who have attended, either live or those of you who are watching this in the future. Thank you so much for being here. Vlad, Michael, your gift of time is incredibly appreciated. And as I see coming in chat now, thank you for the great presentation. Other than that, you know where to find us, and we'll be back shortly. Cheers. Be well, everyone.